Okay, so we're going to talk about sine and cosine graphs. So do you know what like a general sine graph looks like? It looks like it looks like this, where you kind of like take off from here, go down, go under, and go like that. Okay? And so this is the sine graph. Sine graph. Cosine graph is different, a little different. Cosine graph takes off from up, kind of drops down from here, goes down low, and then goes back up like that. Okay? And And it's good to know that those general graphs right there. And in degrees, this would be 0 degrees, 0. This would be 90 degrees. This would be 180 degrees. This would be 270 degrees. And this would be 360 degrees. Okay, and over here, this is 0 degrees. It's the same intervals. And this is 90 degrees. And this is 180 degrees. And this is 270 degrees. And this is 360 degrees. And the height right here is 1. And it bottoms out at -1. The height right here is 1. It bottoms out at -1. You with me so far? Okay, so when we're talking about like the most important 5-degree values, what are they? Yep, 0, 90, 180, 270, and 360. And you can remember those because if you think of a circle or the unit circle, it's 0, 90, 180, 270, and back here again, 360. Okay. Now, do you know how to convert those numbers into radians? Yeah, well, if you want to go from like radians to degrees, or from degrees to radians, then you would go like 90 degrees. Let's say we're going from degrees to radians. Then you put your degree over 1 times, and then you want your 180 degrees right here, because you want it to be opposite these degrees right there. And then over here, you're going to write pi. So these little, so the little degrees kind of wipe out diagonally. And that's just 90 pi over 180. 90 pi over 180, which reduces down to pi over 2. Okay? If you want to go the other way around, let's say you have pi over 2, and this would just be radians, but we usually don't write our radians like that when we do our conversions. But you'd say pi over 2 radians. You want to take it to degrees, all right? So you say, all right, well, think of the radians as being at the top, the word radians. Then we know that there's pi radians corresponds to 180 degrees. So then these kind of wipe out diagonally. And then you multiply across, and you're going to get 180 pi over 2 pi. But now we're in like degree language because of the degree right there. And then these wipe out. And then 180 divided by 2 is 90 degrees. Are you following me? I can explain it again. Hot. Sometimes it makes more sense to see your wiping out happen than instead of writing like the degree symbol, write the word degree and then degree, and they can actually see the degree words wipe out like in chemistry. You got that? Okay. But now that we did all that, you don't need to do that for these guys because you should memorize them. All right, so 0 degrees, I'll put little degree symbols here. 0 degrees corresponds to 0 radians. All right, fine. Same thing. That's cool. And 360 degrees corresponds to 2 pi radians. And then 180 corresponds to pi radians. And then 90, well, if you think about it, if pi is 180, that's pi, then what is half of pi? Like this 9 degrees would be half of pi, right? Like if all of this is pi, then what would it be right here? Pi over 2. So that's pi over 2 radians. Wait, pi over 2 radians. And now we can actually kind of count by pi over 2's. Watch this. I can say this is pi over 2. Wait, let me erase this. This is all busy. So I can say that this is pi over 2. And then I could say this is 2 pi over 2. But 2 pi over 2 reduces down to what? Pi. And this would be 3 pi over 2. And this would be 4 pi over 2. But 4 pi over 2 reduces down to what? 2 pi. Okay. So this would be, so the 270, which is right here, corresponds to 3 pi over 2. And these you want to remember these 5. Makes life easier. Okay? So, quick review. Cosine, the sine function is the one that does the liftoff. Right? So if I do, I'll make this a little prettier than before. If I go like this, go here. I don't really know why I did it like that. Wait, hold on. There. Okay. So this would be the sine function. This would be the cosine function over here. And I know that which one does the liftoff, like at the origin? The sine does. The sine goes like this, like that. And the cosine does the drop down, like that. Okay? So, because if you at least know that, then you can kind of finish the graph off. So sine takes the lift off the origin, goes over, and then goes like this, and under, and then stops there. Cosine function does a drop down, goes under, and goes up like this. And both graphs actually go on forever. So if I were to continue the sine function, it would look like this. And if I were to continue the cosine function, it would go like that. And if you notice, the cosine function, is kind of related to the sine function, and the sine function is kind of related to the cosine function. There's like sineness within the cosine and cosineness within the sine. But they go on forever, both ways. But if you look at their original parent functions, you want to think of these guys. You with me? Okay. Now remember we talked about these 5 important values. Okay. Guess how many tick marks you're going to draw? 4. Because why? How come I was thinking you're going to say 5? Yeah. 0 is 1. All right, cool. So we got that, we got that, we got that, we got that. Okay. So that means that this right here in radians would be, well, that's 0 still, which we normally don't really write that in there, but there it is, 0. And here's pi over 2, pi, 3 pi over 2, 2 pi. If you don't end up at 2 pi, you did something wrong. Pi over 2, pi, 3 pi over 2, 2 pi. Okay. Now, so we know that this graph that I just did right here. Wait, this graph I did right here is the graph of y equals sine of x, which is the same thing as f of x equals sine of x. It means the same thing. And this graph over here is y equals cosine x, which is the same thing as f of x equals cosine x. Okay. All right. So now we're going to do the rest of the lesson with the sine graph. Everything that I'm about to say completely translates to the cosine graph. So we'll just do it from sine. So let me just get this and put this back down here. We're going to do, like, the most basic translation you can do is like a vertical shift, like just moving up. Okay, so if you have something like this, y equals sine of x plus 3. Well, what that means is you get your original graph, but you move the whole thing up by 3. So the original graph, this is called this little curvy thing, this little wavy thing is called a sinusoid. This axis right here is called the sinusoidal axis. Well, the sinusoidal axis goes up by 3. So, 1 second. All right, cool. So what you're going to do is you're going to go 1, 2, 3, and we're going to draw our new sinusoidal axis, which is the new midline, like that. And we're going to draw our 5 important values, or 4 important ticks, I guess. 1, 2, 3, 4. Okay, and notice how this, remember, this goes up by 1 and goes down by 1. All right, it's still going to go up by 1 and down by 1. So here, if this is 1, 2, 3, this would be 4, and this would be 2, and this one here is 3. Right, so that axis is now on 3. So then you can put your little pretend tick marks here to kind of help you out a little bit. And sine, does it launch from the origin or drop down from 1? It launches. And you can draw these little guidelines also above and below, like that. And we're going to launch from the origin. So launch, skip 1, strike through, skip 1, get the other one right there. Launch, so you skip, strike through, skip. I don't know why I drew this so far apart. And you go right there. And that's the graph of y equals sine x plus 3. Everything just went up by 3. Okay? If it was y equals sine x minus 3, then everything would go down by 3. Okay. The second easiest one to learn is changing the amplitude. So if you have y equals like a number, let's say 2, in front of the sine x. Super easy. So that means all the y values get multiplied by 2. And to graph it is actually really easy because you just get your original graph, put your 4 important values in, your 1, 2, 3, 4, and originally we had it going from 1 to negative 1 on the original function. And since there's a 2 here, this value is going to get multiplied by 2. So now we're going to stretch this to 2 and negative 2 and put our new tick marks here. Launch at the origin, strike through, go down, go back up, like that. So it's a taller graph. It didn't move up at all. If I would have done like plus 3 or something, it would have moved up. But all the y values got multiplied by 2. Okay, you with me on that? Okay. So now let's talk about a more complicated scenario. Well, we'll save the best for last. So this one will be y equals sine, and I'll do theta minus pi over 2. Okay? So this has nothing to do with up and down. Since it's in parentheses, it's going to have to do with side to side. And it's going to be in the opposite direction as what you think it should be. So you see how this is like minus pi over 2? And we think that everything should go like 90 degrees that way? Well, everything's actually going to go 90 degrees this way. It's going to be, think of it as like being positive. You're shifting everything to the right by pi over 2. Okay, so originally our graph went like this, right? And this was pi over 2, and this was pi, and this was 3 pi over 2, and this was 2 pi. Well, because everything shifted over pi over 2, the new graph is going to look like this. It's going to go, let me draw my little guidelines on top to help. Okay, and then it's going to be like this. You're gonna move pi over 2 this way. So now you're gonna launch from here. You're gonna launch, skip that one, strike through, and go under there. So this one u value here is going to be whatever the old value of 2 pi is plus pi over 2. And you can add them together with common denominators if you want and say that that's 4 pi over 2 plus pi over 2, which is 5 pi over 2. So it ends up at 5 pi over 2. So that's what that is. You get that? Okay, so basically, if you have like y equals x squared, do you know what that graph looks like? Does it look like a U? Yeah, it's a parabola. So that's a parabola. And do you know what, hold on a sec. So that's what that is right there, right? And then what if I did y, whoa, what if I did y equals x squared plus 2? You know what that graph would look like? Yeah, just like over here, how this went plus 3, it was the same thing but 3 up. See, so this one goes up by 2 and 2 up, all right? And let me just kind of move those up. What if we had, or what if we had y, why does it keep doing that? What if we had y equals x plus 2 or x minus 2 squared? You know what that would do? It would move it in the opposite direction that you think it should move in because it's inside the parentheses. Well, this is the left and this is the right. Yeah. So it moved to the right by 2, right? That way. Okay. So then it looks like this. All right. Same thing with the one we just did with the sine graph. So because it's at theta minus pi over 2, it's going to move in the opposite direction that you think it should, which means it's going to go to the right by pi over 2 by 90 degrees. You get that? Are you sure? Okay, I want to make sure you get that. All right. So now the hardest one is when you deal with the period. Okay, so what is the normal period of a sine graph? And that means like how many degrees does it take until it like repeats itself? You know what that is? Like the sine graph, you know how it like launches and goes like right there? Like how many degrees is right there and then it repeats itself? Yeah, 360 or 2 pi. So the normal period is 2 pi. So what we can do is, so if we have something like this, like y equals sine of 2 theta, like that. Can you see? Okay. What you want to do is you want to flip this number. And then what does that 2 become when you flip it? It becomes 1 over 2. And that means that your period got chopped in half. Okay, so if the normal graph is like this, so look, if the normal graph is like this, the new graph is like that. Same height though, so more like, how do I do this? Like that. The period gets chopped in half. Okay? All right, so, and let's see. And there's one more thing. If you have something like y equals negative sine theta, so you have something like that. Wait, I guess I should, hold on. I should keep these notes. So if it's flipped, it gets flipped by 1/2, and this, the original one goes like this, and then the new one goes like this. This is pi. So the new period equals 2 pi times 1/2, which is pi. Okay. And then the last thing, before we jump into the problems, is if you have y equals negative sine of x. See that? Do you know what that does? So like, let's say your normal graph is like this, right? That's your normal graph. All it does is it flips it upside down. So your new graph goes like this. So I always just draw my normal graph and then I kind of complete the DNA molecule. But this is actually the new answer right there. Okay. So let's just tackle these problems now. All right, so this says find the equation for a sinusoidal function that has a period. Oh, wait. All right, so find the equation for a sine function that has a period of pi, amplitude of 2, and contains this point. Okay, so, well, we know like this is the general equation of a sine function. Y equals sine x, which is the same as f of x equals sine x, right? Okay, if it has an amplitude of 2, do you know how we can apply that to this problem? Say that again? Yep, 2 goes in front of the sine. All right, took care of that. All right, and it has a period of pi. Okay, so if it has a period of pi, then what happened? How do we acknowledge that? Here, let me show you something else. So I know that for these sine and cosine functions, I can think of like well, first of all, there's like a general equation that's like something like y equals, let me see if I get this right. It's like a sine sine b x plus c plus d, something like that. Hold on. Okay. So it's, oh, I did it right. Okay, there it is. So this number right here is your amplitude, which is what we got right there, right? And this number right here, b. B is what's referred to as, let's get some silly name, I don't know. But B, when you think of B, think of the word boot. Okay? And when you think of a boot, draw a boot. There's my boot. Wait, that's a dumb boot. I'll make it a little bit less dumb boot. There's my boot. And a 2 pi can fit right there. And a period, the word period fits right there. And that helps me remember that B is 2 pi over period. Because I used to get confused and think that B was equal to period over 2 pi. That's why I drew the boot, because you cannot fit the word period here. So it's 2 pi over period. You're with me? Okay. So it says here that the period is pi. And we want to find our B value. So we're going to say that B is equal to 2 pi over what's the period they gave us? Pi. And that wipes out, and that means B is equal to 2. Okay. And so and they want the formula to be like this one here. Right? So we're going to have y equals our a, which we know to be 2. We have our sine, and we have our our b, which is 2x plus c, and I don't know if it's going to go up anything, maybe. So then we go over here, we graph it, and let's think about this for a second. Hold on. So if the period is pi, did the period get bigger or the period get smaller? Well, what's the normal period? Yeah, because what's the normal period? Normal period is 2 pi, yeah. So now the whole sine graph is going to end at pi, right? So that means that all these values that were right here and right here and right here, they all got kind of cut in half, right? So this value was pi over 2. Guess what it is now? It's pi over 4. And guess what this value is now? Pi over 2. And guess what this value is now? You said 3 pi over 4. Good. 3 pi over 4. Okay. So there it is. So, and it's saying that this graph now goes to 3 pi over 4 comma 3. So you have your 1, 2, 3. Da, da, da. All right, so they're saying that our new graph goes to this coordinate right here, right? Okay. So, hold on. So what do you think we can do to this graph to make it like we basically need this point that's right here to go through this point right there. Move it up. Okay, cool. You said move it up 4. Think about this. Well, its amplitude is 2, right? So it said here the amplitude is 2. So technically, before moving it up, it's now like this to here and here. So it went like, yeah. There's our current graph, where this is -2 and this is +2. Okay? So how much would we have to move it for this bottom part right here to hit right here? Well, if it went up by 2, it would be here now. 5. Because look, if it's here now at -2, if you move it by 1, it's here. You move by 2, it's here. 3 here, 4 here, 5 here. You have to move it up by 5, right? And then if we did that, we would have our new equation of y equals 2 sine 2x plus 5. And then there's no side-by-side shift. Okay? All right, hold on one second. All right, so I put it through Desmos, what our graph is. So 2 sine 2x plus 5. And you see how it crosses through 3 pi over 4 comma 3, right there. And that's what they wanted, right? So they want to cross to this point. They want it to have an amplitude of 2, and the amplitude is from the midline here, like how much up it goes, right? And that goes up by 2. And they want to have a period of pi, which is half the normal period, which means it repeats itself every pi. And that's what this is right here, because if you go like, can't really tell in this graph, but the period's pi. Okay, so hold on one second. Okay, so that's the equation for this problem. This is right here. Okay, we're gonna do another one. Okay. So find the equation of the sinusoidal function, and again, they want sine, right? So sine has a period of 3 pi and an amplitude of 2. Well, I know how to deal with the period part because I can use the boot. Remember, so the general equation is y equals a sine bx plus c plus d. And this b right here, think of the boot. And what is the boot equal to? Over, yep, 2 pi over period. So you have 2 pi period. And we gave us a period in the problem, right? What's the period in the problem? Okay, so we're going to say that 3 pi over, just kidding. They say that we're trying to figure out our b, right? So our b value is equal to 2 pi over 3 pi, which is our period. Oop, oop. So what is our b value? Two over 3. Okay, and we know the amplitudes too, so we can kind of do this a little bit. So what do we think? What do we have so far? Good. 2 over 3x. Okay. So let's go ahead and we need to go through 3 pi over 2 comma negative 2. All right, so we're going to go ahead and draw our graph right here. And we're going to draw everything except the vertical shift. All right, so if the period is 3 pi, then we know it ends at 3 pi, right? So our graph is going to go like this. It's going to go like this. It's going to go like this. And it's going to end at 3 pi. Right? Does that make sense? Okay. And do you see this 2/3 number right here? Okay. So what you can also do, and this is kind of weird, but which is this number here. If you flip it, if you flip this number, you can multiply all your original important numbers or critical values by this. So you know how like the original numbers were 0 and pi over 2. What was after pi over 2? Pi. What's after pi? What's after that? Okay. And if you multiply them all by the flip of your b value, you'll find out where their new corresponding values are. So for example, this b value is 2 over 3. Well, I'm going to multiply my 2 by the opposite of that. So by 3 over 2. And if I do that, what do I end up with? over 2. 6 pi over 2, which is what? 3 pi. So that's going to be the new period, which makes sense because we already know that. See? But now what we can do is we can multiply all these things by 3 over 2. So you multiply this by 3 over 2, you multiply this by 3 over 2, this by 3 over 2, this by 3 over 2. Okay, and then what do you get right here? Okay, and what do you get right here? And then right here. This right here. Okay, and this is 3 pi. Okay, so that means that if I go like this, like this, like this. Okay, so 0 is still 0, but what once was pi over 2 is now 3 pi over 4. What once was pi is now 3 pi over 2. What once was 3 pi over 2 is now 9 pi over 4. Then it ends at our period number, which is 3 pi. Okay, now we go over here at the problem, and it says that it goes through 3 pi over 2 comma negative 2. Okay, so that means we have this right here, look. And we know that, do you know how high this is right here and how low this is right here? Yep, 2 and negative 2. Okay, so what do we got to do to what we have? So what we have so far is this graph. Like, we have this graph. We just need to know how much to move that thing down so it goes through the point 3 pi over 2 comma negative 2. Right now it's going through 3 pi over 2 comma 0. So how do we make that thing go through 3 pi over 2 comma negative 2? Bring it down by 2. Yeah, if we bring it down by 2, so then what do we do to this equation to bring it down by 2? Good. Yep, add a minus 2 right there. And that'll bring this whole thing down by 2. That's the answer. Okay. So that's our point right there. 3 pi over 2 comma negative 2. 3. Okay, so wait, 3 pi over 2 comma negative 2. All right, hold on. Okay, for this one here, it says find the equation for the sinusoidal function, which is a sine function. Okay, that has a period of 4 pi, amplitude of 2, and contains point negative 2 by comma 0. Well, what's the general equation of a sine function, like with a, b's, and d's, and c's? No, like y equals a sine, just with letters. Do you know it? Just with letters, like no numbers, just the general, like with a and b, just b, yeah, bx plus c plus d. Okay, so, all right, so what do we know so far? There's some stuff that we know. Okay, where does that go? For what letter? Amplitude is 2. A. So 2 sine, and what can we do? What can we figure out? Yeah, we can figure out b. How do we figure out b? B is equal to the boot, which is this guy, which is 2 pi over period. Yep. So b is equal to 2 pi over 4 pi. Okay, which is equal to what? Well, the pi's wipe, right? Yeah, well, the pi's wipe. If it's 2 pi, yeah, so 2 over 4, so yeah, it equals 2 over 4, which equals 1/2. Okay, so we found our b. We know b is equal to 1/2. B is equal to 1/2. All right, so 2 sine, then we have 1/2 x and plus c, but we haven't really done a side-by-side move. We probably can do it with that one. So I got rid of I just didn't do that. Plus d. So we just got to figure out our up or down move when we're in business. Okay? Okay. So we go over here, and we know that our normal sine function, does it launch from 0 or drop from 1? Does it launch from the origin or launches from 0? So it goes like this, goes. And we know that this particular one stops where? Good, at 4 pi. Which means that we know what this is, just thinking about it. 2 pi, which means we know what this is. And we know what this is. That's 3 pi. All right. And our amplitude is 2, right? So what's up here and what's down here? Yep, 2 and -2. So this is +2 and this is -2. And this is where we are before we do our vertical translation. Now, our graph is going to have to cross through -2 pi, -2 pi comma 0, right? So, well, our graph can still continue on. So this could be -pi. So this could be -pi. This could be -2 pi. And this could be -3 pi. And this could be -4 pi. And then the graph would strike through here, touch down, strike through there, and go over. Well, it looks like our graph rate does what? It crosses this point. See? Because what is it like? What's that? Yeah, because it already crosses. This is -2 pi comma 0. So we didn't have to shift it or anything because the graph actually goes in all directions. We just let it go. So you don't have to do a side-by-side shift unless it doesn't cross through it. Okay? So it's kind of good as is. So we have y equals, what did we say? So it's 2 sine 1/2 x. Bam. No vertical, you don't have to do plus anything. Just leave it like that.